All right, let's do total area between the curve of a function and the x-axis. And for this particular example, I want to do some transcendental function. So we're going to find the total area between f of x equals ln of x over x. All right, and so it's kind of like a rational / transcendental function. And we want to do that on the interval from 1 over e to e. So e is about 2.718. You can imagine that 1 over 2.7 is around 1/3 or so. And then e, of course, is 2.7. So we're basically going from around 1/3 to around 2.7 for our interval. And we want to find the total area between this graph and the x-axis. So again, the difference between total and net area. Total area, all the area under the graph is considered positive. Net area, the area below the x-axis, cancels out the positive, or at least subtracts from it. So step 1, we're going to figure out the x-intercepts, where this graph crosses the x-axis. That way we can break it up into several intervals. Where does ln of x over x equal 0? Well, only when the top equals 0. So where does natural log of x equals 0? Basically, to solve this, you'll raise both sides to the power by the you'll raise both sides by the power of base of e. And e to the natural log of x is equal to just x. So x equals e to the 0, which is 1. And you could have just looked and known that natural log of 1 is equal to 0. So that means it crosses the x-axis at x equals 1. So that means we're going to break up our interval we're going to break the interval up, the original interval, which is 1 over e to e, into 2 separate intervals. So our intervals in integration are go from 1 over e to 1, where it first crosses, and then from 1 to e. So here are so remember, if it just crosses once, you'll have 2 separate intervals. You're going to have one going from 1 over e to 1, and then one going from 1 to e. Because it's total area, we are putting absolute value bars around each integral to ensure that we get a positive number back, to ensure that we are doing total area and not net area. And you're going to definitely see a big difference for this one. And we'll go ahead and just look at the graph. So if you look at from 1 over e to 1, you can see this area is negative. In fact, it's negative 1/2. So in order to make it total area, we're just going to make that positive. The second one's already above the x-axis, so if we take the absolute value, it's still going to be positive. Now, if we were to find the net area, you can see that these would cancel each other. Negative 0.5 plus 0.5 would be 0, and we get a completely different answer than if we just if we break it up and do, one plus the other. So this is why we break it up. If you didn't break it up, you would if you just went from 1 over e to e and found the definite integral and tried to take the absolute value, you'd get the absolute value of 0, which is 0, which would not give you the right answer. So this is why we have to break it up. Okay, so let's go ahead and move on to step 4, which is to integrate this. So this one's a little tricky because it's natural log of x over x. So you will have to use u substitution. You can't just take the antiderivative. Now, how do I know to use u substitution? Well, what's the derivative of natural log of x? It's 1 over x, right? Since we have an x on the bottom, u substitution will work since it will end up canceling the x on the bottom. So let's move on to step 4. Determine the definite integral of each expression. So again, you're going to make u equal to natural log of x. You're going to take du dx of both sides, and du dx equals 1 over x. You're going to cross multiply, and you're going to get dx equals x du. And at that point, since dx is equal to x du, it's going to be replaced by x du. And again, I mean, really, like the left and right of this are the same. The only thing that's different is your limits. And then you're going to replace natural log of x with u, since that's what you set it equal to. And so now you have u over x times x du for both of these. You can see now that the x's are going to cancel on both of these, and you're just going to end up with a u. Now, one thing to note, however, is that, again, when you're doing u substitution, if your limits are in terms of x, they have to be changed in terms of u. So we will have to do that before we can move on to integrating this. So these have to be in terms of u. Right now they're in terms of x. So we would do our little fishy and change these limits, since our original formula for u is u equals natural log of x. we will just plug in our limits into this formula. So this goes from x equals 1 to u equals 0, which is what we want. And on the bottom limit, it goes from 1 over e. If we take natural log of 1 over e, we get negative 1 back. It's the same thing as natural log of e to the negative 1, which is just negative 1. Okay, we're going to do the same thing with our second integral. In other words, the integral that represents this area right here. And we're going to change these again from x to e. And our new limits are going to be u equals 1 and u equals 0. And that we get that by plugging it into our original u formula. So now we can integrate. This is going to be super easy. Just use the reverse power rule. Antiderivative of u is 1/2 u squared. Don't forget to take the absolute value of these to ensure that we are making any area that's negative positive for total area. Okay, so the first one, you're going to plug in 0 and then plug in negative 1. And you're going to get negative 1/2 back. For the second one, I'm not sure why I didn't show that on this one. I guess I ran out of room. Okay, for the second one, you're just going to get positive 1/2 back. I mean, it won't matter because absolute value of 1/2 is still 1/2. So for step 5, just make sure you take the absolute value of each of those, and that's because we're talking about total area. So you get 1/2 plus 1/2, which is equal to a nice clean 1. So the total area between the x-axis and natural log of x over x from 1 over e to e is actually just equal to 1. If you have any other questions about this example, let me know.